Ladies and gentlemen, I'd like to introduce Major General David Thompson, Vice Commander of Air Force Space Command, to make a few remarks.
All right, good afternoon, ladies and gentlemen. First, I'm going to add a general welcome, first of all, to our distinguished panel. All of our space leaders who have joined us for this great week, whether you're a Hardinger Award winner or a space pioneer or one of our past or present leaders, thanks for coming and participating in this event, as well as all of the men and women out there of Space Command headquarters, our guests from the industry and some of the wings. By way of introduction, I would like to, if you would imagine with me for a minute, that we had the ability to control time and space, and we had a panel up here on the stage that consisted of the following individuals. We would start with individuals like Thomas Edison and Nikola Tesla and all they did to revolutionize and empower the world. We would move on to innovators like Marconi and Alexander Graham Bell and what they did for the communications industry. This panel would include people like Henry Ford and the Wright brothers, who had a tremendous impact on how the world changed with respect to transportation, as well as folks like Alan Turing and Steve Jobs and everything they did and meant to communications. Well, in the case of space, we don't need the ability to warp time and space. In fact, when you talk about space, that is the magnitude and the import of the panel that we have here today. We have, as I said, I'm not doing the details, but we have the father of GPS, the architect of the Defense Meteorological Support Program, the first mission controller for the world's first photo reconnaissance satellite, as well as the individual who designed the system to ensure that it could point and look exactly at the targets that we want them to look at when we want them to look at. We have visionaries here for the Air Force's first and only operational anti-satellite system, and across the panel, individuals who innovated, who revolutionized, and changed the world when it came to space. That is the level of magnitude and the import of the panel that we have today. Imagine with that previous panel with Ford and the Wright brothers and Marconi, what you would like to hear from them in terms of their experiences, what they were thinking, how they believed they might impact the world, as well as the questions that you might ask them. You don't have to imagine that today. You have those individuals here. They're going to share their perspectives and their thoughts. What they were thinking, what was important, what they were concerned about, whether or not they really believed that they would have had the impact that they truly had. And you'll have the opportunity to ask them questions specifically about what they did, what they were thinking, and what it may have meant to them. So ladies and gentlemen, if you would, we're going to bring Dr. Sturtevant up, and he's going to lead us through the panel. But if you would please join me in welcoming our panel and all of our guests and heritage leaders here today.
Lower the microphone to my level. I wish I was taller, but I'm not. Thank you, General Thompson, for your remarks. Good afternoon, ladies and gentlemen. Welcome to the 2016 Space Heritage Week's Air Force Space and Missile Pioneers panel. I'm Dr. Rick Sturtevant, as the General said, Deputy Command Historian for Air Force Space Command, and I'll be your moderator today. As you know, many of the programs that we manage and support today can be traced back, as the General said, to far earlier times. Our Space and Missile Pioneers, represented by this panel today, were directly responsible and or significantly involved in the origins of those programs, as well as many others, some of which we can't talk about even today. That is the reason for the roundtable session, and let me begin by introducing our esteemed panelists. First, our 2016 Space and Missile Pioneer Award recipients. General Retired Thomas S. Moorman Jr., who could not be with us today, played a key role during the late 1970s and early 1980s in various studies and programming efforts that resulted ultimately in the establishment on the 1st of September 1982 of this very command, then called Space Command, because it was the only military space command in existence at that point. As Commander and Vice Commander of Air Force Space Command later on, he was responsible for the operation of a variety of military systems. General Moorman is represented today by his son, Mr. John R. Moorman. John, could you please stand? Our next award recipient, honoree today, is Major General Retired Robert A. Rosie Rosenberg, who served as Mission Controller and Targeteer for the Corona program, Gambit, and SIGINT satellites, and was directly responsible for many of the aspects of the Hexagon program that followed on Corona. As a member of the President's National Security Council, he assisted in the establishment of the Space Shuttle program and formulation of President Carter's National Space Policy. General Rosenberg. Award recipient today, Major General Retired that's Major General Retired Thomas E. Taverny. He was a former recipient of the Air Force Scientific Achievement Award for developing and demonstrating a new guidance approach that subsequently allowed proof of concept for an air-launched anti-satellite weapon system. He also led development of the extremely successful commercially hosted infrared program, Payload. General Taverny. Now I'd like to introduce our returning pioneers on the panel, and thank you so much for coming. First, we have Mr. John Herther, a 2003 honoree. Mr. Herther designed the three-axis stabilization system that enabled Lockheed's Agena space vehicle to become the Corona Reconnaissance Program's workhorse. Next, we have Colonel Retired Wilbert Bill Craig III, a 2006 honoree. Colonel Craig was a member of the original Air Force Space Surveillance, or Space Track team, and was chief analyst for the first operational anti-satellite system in the Air Force, Program 437. Next is Colonel Retired Tom Haig, the 2000 honoree. Colonel Haig was chief of the Requirements Office for Satellite Control Ground Support during the late 1950s in the Corona program. He led a small Air Force team to develop what would later be called the Defense Meteorological Satellite Program. And our final panelist today, last but not least, Dr. Brad Parkinson, 2008 honoree. Dr. Parkinson was the program manager for the Navstar Global Positioning System, synthesizing elements of competing space-based systems for precise positioning, navigation, and timing. Let's give another round of applause for the entire panel. You'll have a chance to ask these pioneers questions, and I hope you will. I have enough that we could fill an hour and a half. But I hope that many of you out there will feel free to ask the questions once we get started here. It's a unique chance that you have here to ask these pioneers questions about their involvement in some of the early space and missile programs that maybe you've only heard about. As a reminder, however, this is an unclassified forum, so let's not get too far into the black world here. Finally, I'd like to introduce some of the Hardinger Award winners that I see in attendance in the front row, and please hold your applause until I've completed the introductions. I see Lieutenant General Bruce Brown, Lieutenant General Mike Hamill, Major General Carl Neil Beard, Major General Wesley Clark, and I think I see an former NRO Director, Keith Hall. Hope there's no one that I overlooked there.
Jeff Harris.
Jeff Harris. Okay, so let's get started here, and I hope that you'll all feel free to chime in. But now that these introductions are over, I think I get the privilege of asking the first question. And with all of the chatter that we had about how Rosie Rosenberg goes on and on, I'm going to ask General Rosenberg the first question. General Rosenberg, you obviously played a major role in the Hexagon program. And could you tell us some of the challenges that you faced there and what you did to overcome them?
Well, let's see, I was working for Bill King, the director of NRO Program A, and he called me up to his office and he said, Rosie, I don't like this draft RFP you have. It was the Hexagon Mission Planning, Targeting, and Command and Control System, which I put together the RFP because of my background in targeting for both Corona and Gamut, and knew that this was a system that kind of combined both. He said, I don't like your draft RFP. I want you to bring it back, and I want you to put out a revised RFP that requires a detailed design and a detailed acceptance test plan. I said, General King, that's what you pay the contractors to develop. You can't get contractors to submit that. That's what you pay them for. He said, son, that's what you're going to do. I said, listen, you put me in charge of all the NRO software so you'd have one guy to kill. Don't tell me how to do my job. Court-martial me if I fail, but stay your mind out of my business. The general gets up, I stood up, my boss got up, pointed his gun at his you-know-what, and said, Rosie just shot himself there. General King came around, put his arm around me and said, son, I love you too much to do that to you. You're going to do it my way. I put out the RFP with this ridiculous detailed requirement, and 5 contractors delivered detailed designs and detailed acceptance test plans. I couldn't believe it. Okay, so we have our first kickoff meeting. 250 contractors. TRW was the prime contractor, and all the SCF support contractors were there, and PerkinElmer and Lockheed, the hardware contractors were there. And I walked into the room, and I know the Colonel's going to really like what I have to say. My Aerospace Corporation guy was sitting at the head of the table, and I said, get out of my chair. He said, this is my chair. This is a TD meeting. I said, get out of my chair. This is my meeting. I run this program. And I had to scream at him in front of 250 people. Finally, he got up, went over and got another chair and put it right next to me. And during the meeting, he starts giving orders to the chief systems engineer from TRW, who's saying, yes, sir, I'll do that, yes, sir, I'll do that. I turned to the TRW program manager and I said, if your systems engineer ever responds again to my technical assistant advisor saying he's going to do what he wants, I want that systems engineer fired. My aerospace guy got up, stomped out of the room. Half an hour later, the general called me. Come up to my office, so I had to leave the meeting. I went up to the office. He said, Rosie, how come the president of Aerospace Corporation told me the best thing to do to improve relationships between SP and aerospace was to fire Rosenberg? And I said, boss, you hold me accountable for cost, schedule, and performance. And Aerospace Corporation can give technical direction to my contractors with no accountability at all, no responsibility for cost, schedule, and performance. And, this is criminal. All they know how to do is make it more expensive. And he said, well, what would you do about it? Well, for 4 years, I had kept in my pocket a revised statement of work for Aerospace Corporation. Here's the whole statement of work. It changes their contract from SETD to SETA. CETA, not technical direction. He said, some of the SPOs complain about this. That's not a bad idea. Let's go up and see Ken Schultz. We went up to see General Schultz, and he said, great idea. Aerospace Corporation has hated me ever since then. But by God, You know, the point is that the Air Force needs to be running these programs, not any contractor. And that's the way I've always felt, and I know the Colonel agrees with me. But at any rate, we delivered the software a year before the satellite was ready, thanks to General King. And we were able to rehearse and operate and fly the satellite perfectly. Okay? I answered your question.
That sounds good. I know Colonel Haig agrees with him, because in a panel a number of years ago, we had a discussion about systems engineering and whether it should be dealt with by the contractor or we should have Blue Suit in-house. And so I know Colonel Haig is in agreement on that, and it looked to me like the way some of the other panelists were nodding that they would agree too. If you'd like to comment.
It's interesting, you don't recognize this, but Rosie and I are Naval Academy classmates. We've known each other for about 60 years, and this is the first time I heard this particular story. But I was the revolutionary leader for something called GPS, and it was a revolution, and it had all the problems you would normally associate with it. We did have aerospace, and aerospace offered me a contract that said TD. And I said, no, you're not TD. Air Force officers are TD. And in addition, in our particular situation, there was a control system and user equipment and a test program and satellites. The initial idea by my boss, the same General Schultz, was we would hire an integrating contractor. I said, no, sir, we're not going to do that. I hope, because if we do that, we'll lose control. Meanwhile, the Aerospace Corporation said, well, we will just do this TD and you don't have to worry about it. I also went to General Schultz and I said, I'm sorry, sir, that I can't accept this aerospace contract. And yet again, it went between myself and the president of aerospace. This is coincidental story. But the point is this, I think. If you're in charge of something, you have to defend the fact that you're responsible for the whole program. And incidentally, I am delighted to hear the boss here reinforce that. He was talking about test concepts and how you develop those. And he was saying, no, the way this is going to happen is I'm going to delegate it down to those organizations and they're going to do it. And I'm not going to tell them how to do it. And I think, frankly, as a leadership exercise, that's exactly the way to do it. Fortunately, I had, at that time, some very brilliant engineers, Blue Suit engineers, that could stand up to any contractor in the room. And but there wasn't a conflict. It was that they all got together, unified behind a common purpose, which was to build GPS. Because if you're trying to do a revolution, you lose a few battles and pretty soon you don't have your revolution anymore, because the Air Force didn't want GPS. The Air Force didn't want GPS at all. And I had major generals putting their big fingers in my chest as I wandered the halls of the Pentagon saying, Parkinson, your otherwise great career is about to go right down the tubes if you keep advocating this thing, because we want that money for something else. So the point is, if I were to give little pieces of advice, they would not come from me. One would be what Winston Churchill answered when he was asked, why are, Mr. Churchill, he went back to his old school, and the schoolboy said, what made you successful? And he said 9 words. He said, never, 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 never give up. And it's important, if you have something you really believe in, that you do that. And so frankly, I followed that. And fortunately, I had a bunch of young officers who were brighter than I, and they were able to carry the day. And it was a desperate thing. But the other lesson, perhaps, is a lesson from football, and that is Bear Bryant. When asked why he was successful, He said, well, it's the teeny weeny things that will kill you. And what he was talking about is, as a leader, whether it's an operational leader, a development leader, in my opinion, it is trying to sniff out what the real little problem is that's going to stub your toe and fix it before it ever happens. And if you're surrounded by really bright people, I think that's what causes good things to happen. Thanks for letting me interject.
No, that's what we want. We want some give and take here, so. I'm going to ask one more question, this time of General Taverny, since he's one of the new guys on the panel. Back in 1970s, you came up with the design concept for an airborne anti-satellite system. Could you tell us a little bit more about that? How you conceived that, why you conceived it, and where that idea went?
Sure. I still have to follow these two Naval Academy guys, so I'm not nearly as dynamic or fun. But when I came out to SMC in '68 as a second lieutenant, I was the only second lieutenant in plans. And so my office was the safe room. So they found a way to squeeze a desk in there with all these safes surrounding. So being a young bachelor at that time, I didn't see any great reason to go home at 5 o'clock. So when everybody else left at 5, I started opening the safe drawers, pulling out documents and reading them. And there were 6 safes. So after about 6 months, I had been through all of these safes. And the first one that really interested me was a thing called SOS 70, which was a study about, at that time, the future was supposed to be in the 70s. So they were talking about this miniature homing vehicle that was designed for ballistic missile defense, and that Aerospace had analyzed it and had decided that it wouldn't work. And the reason it wouldn't work, it was a can, and it spun real fast, but when you have a can that spins real fast like that, it kind of mutates, so it kind of moves like that. And so these 4 lines of detectors couldn't tell the movement from mutation from the movement of the target. And again, like many here, as we get to second lieutenants, don't have a filter and don't know why everything can't work. So I was a second lieutenant, I said, well, geez, why didn't I just put a curve strip there? And everybody kind of looked at each other and said, you know, that could work. So we had some studies, and I got to have my own program, 100K program, to look at that. And we found a way with those curved strips on the miniature homing vehicle that the miniature homing vehicle actually could work and hit to kill. And so on my way to brief in DC that we now had a system that could work for the DoD for ballistic missile defense, I stopped at the Army in Huntsville at ABIMDA because they had asked to find out what was going on, and I briefed them on it. And if most of you won't remember those days, there was a lot of competition for who would be responsible for ballistic missile defense. So I briefed them on this. I got to DC and I got a call from the project officer there. He said, don't bother briefing, the Army's funding this and we're going to build it, before I got a chance to go to the decision makers. So I went back to LA with my tail between my legs, having messed the Air Force out of this mission, and started thinking about another document I had read in that room called RPAT, which was an F-4 flying missile up to do ballistic missile intercept. They also decided that wouldn't work, but the idea of an aircraft flying a missile, and my little miniature homing vehicle just stemmed an idea in my head. As a lieutenant again, I didn't know any better. I didn't know lieutenants weren't supposed to do that. So I said, well, what if we put an MHV? We could probably shoot down a satellite. Because at that time, the nuclear satellite capability just got shut down in 1969. It was a Thor with a 4-megaton head. They had looked at a follow-on program called DSDD, which was rods. So they were going to spin these rods up and have them go out and be non-nuclear. So all those things kind of just coalesced and said, well, we could do that. And so it took 3 years of getting ejected from most offices saying Air Force lieutenants don't design systems. In fact, at General Albert's office once, I was in General Albert's office, I ended up working with his daughter. And she said, and General Albert said, you know, went to his pilots, what do you think of this? And one of the pilots said, well, that missile won't fit on the wing of the F-106. And I said, you've got to be kidding. You know, it carries a 2,800-pound tip tank, and this missile's only 1,400 pounds. So they decided to throw me out of the office. But after years, after I was long gone, they kept carrying that concept forward, and it ended up being an F-15 in SRAM, and they actually did the intercept in 1984. I was invited back to sit in the control room at SMC and watch the intercept, so that was kind of cool.
I think General Rosenberg has a comment.
So I want to tell a story about that. And that is, when I'm working for the peanut farmer in the White House, that's an affectionate term. He wanted an anti-satellite treaty because he wanted to make sure we never militarize space. And I kept saying, boss, space is already militarized. He said, young man, I want you to run the interagency group to put together a treaty that will ban all weapons from space to space, from Earth to space, and from space to surface. Well, we were working on the MHV program in the Ford administration, and I persuaded the Carter administration not to cancel it. And I was putting together national space policy, and the President approved the statements in the national space policy of guaranteeing the right of free passage of U.S. flag carriers and our friends through space, and denying that to people who would do us harm, hoping that we could trade the Soviet ASAT for our ASAT. Well, after he signs the document, I get a call from my boss, Zbig Brzezinski. Rosie, the President is very angry with you. The Secretary of State told him that you got the President to sign a classified annex authorizing weapons of mass destruction in space. Well, it was the ASAT program. So I called Lynn Kempko-Vaught, who was assistant integrator, and I said, I don't want an engineer anywhere near this thing. I want 5 cartoon view graphs. One is a brick with a smiling face and Mercury wings on it. The second picture is an F-15 squirting this thing off of it. The third is the smart brick smashing into a satellite. And I want a full-scale mock-up of the tomato can, you know, with its, what was it, 64 solid rocket, mouse farting rockets around it with the IR seeker head. And I called Harold Brown, SecDef, and I said, Mr. Secretary, I need you to come over to President Carter's office. I need to explain to him that this is not a weapon of mass destruction. So we go in to the boss's office, and I start going through the view graphs, and he sees this full-scale mock-up, and he runs over to us. Oh, Harold, this is really neat. We need one of this. This is cool stuff. And I said, sir, that's what the Secretary of State told you to fire me over because he said it was a weapon of mass destruction. Oh, no, we need one of these, Harold. We need, this will be good stuff in case the Soviets don't back off their system. So that's how we persuaded the peanut farmer that he authorized.
Do I have any questions from the audience at this point? Or are you all intimidated? All right, I've got one, I guess, from Mr. Herther. Jack, explain to us a little bit about when and how you came up with the 3-axis stabilization concept. And maybe in the introductory remarks, people didn't really get how important that has been to our satellite systems, both in the military and commercially.
Okay, I sort of did this 13 years ago, and fortunately, I have a video of the panel where I did that. And I put a link on my commercial website that's only for the people here, sort of official use only, although it's no security classification, it's just a convenience. And one of the things is that we use that plus documentary material off of the TV program about it, so you can understand how it worked and what it did and the intelligence value and whatnot. And then following that, there's a short version from a 2007 where I talked about Loran and that I have been working at MITRE for 30 years, 15 of which was GPS evaluation of vulnerabilities and improvements, because it's the most wonderful system that I know of for both airborne and on the open sea, but not in among mountains or urban areas and whatnot. And Loran complementing it could be a very worthwhile thing. And incidentally, just in the last year or so, a couple years, there's been some experiments run on a yacht where there's a new technique where some students build a jammer for a small amount of money. They can jam a GPS on a ship with the best commercial instrumentation of GPS on this expensive ship, and no one aboard can detect that it's happening. Well, I'm in the commercial business of preventing oil spills from either navigation or collisions or whatnot. This to me, particularly since in the last couple of months, in the open press and so forth, there's been thousands of jammings, not spoofings yet, but of GPS from the North Koreans. And what I'm doing about it, because I don't think the Air Force or the government will do anything about it. This is one threat that you can just take off the table on GPS. You can't touch it if you combine GPS and Loran. And you fix that by just buying and when I was doing this, $700 receivers, which are GPS Loran, that would do the job. And I think my best advice is just warn ship owners to just go to spend $600. It's too hard to convince the government, as we're finding today, to do anything, much less nullify completely a threat and get all its other benefits. Like in military use, I was pointing out in this video, it's 20 times more accurate than a compass for targeting, and using itself as it was done in Laos. And that's important because just recently I see that we really bombed Laos with more tonnage than Japan and Germany together. This was something Obama just blurted out recently. So this putting Loran in is becoming more and more important. And I really don't have an axe to grind in. It's just that I have studied it for 15 years, and there's really something to it. I frankly, even GPS people should be welcoming Loran, either Loran. But anyway, that isn't what I started to talk about.
No, but somehow, Jack, I knew you were going to go there. Let's hear about three-axis stabilization.
I'm going to go there. So
how you came up with that in about 1955.
Okay, yeah. Starting in 55, there's a video that you can get to. Go to automate.com/space, and you can target, there's 2 or 3 links on that subject, so you get the old history. What I thought today, I'd talk about something that would complement that wasn't available 13 years ago. And the Loran thing is part of it. I won't do that again. One interesting thing that's related to the militarizing of space, and I'll go back to the Corona program, that I actually started on that in 55 because it was at MIT, and I had to do a thesis. And at that time, Draper had contracts in what's called the MIT Instrumentation Lab. It's now called Draper Lab. But anyway, the contracts were for ICBM guidance, and we were starting out with a thing called Skipper, was the Atlas, which didn't turn out to be inertial. Titan, I think there were several versions of it. Titan 2 or so became all inertial through Draper Lab. And they even did things for the Navy, like the submarine inertial system, which was a 2,000-pound IMU. It was huge. And just to make sure, they voted 2 out of 3. So there was a 6,000-pound, 2 out of 3 voting IMU on subs. So the idea started from what we're going to do, because the mission contract they had was to do guidance and stabilization for satellites, for military purposes, for reconnaissance. And the basis of that was the RAND studies, and Bob Salver, I think, happens to be sitting next to me during that 2003. We worked very closely to RAND to implement that. And just to pick on the point here, we did this after I got my degree. I had done that based on using the SINs, because the father of SINs was there, Joe Delisle, in Draper's lab. The idea was to take one of those SINs, 2,000 pounds, and shrink it to 200 pounds. The idea being we were going to use a principle that Draper often used, which is called synergism, and you almost never hear that word anymore. And synergism, as Draper used to explain it, was if you take two concepts that almost solve a problem perfectly, if you mix them, combine them in some clever way, you're always going to find they're better than either one. And there's my Ram pitch in a one-liner. But anyway, that was the concept for ascent guidance. The concept for stabilization was something that Rand had the original idea. We merely implemented it. It was essentially have a dumbbell, and we actually made one to take around to briefings for Secretary of the Air Force then, because they say, how does it work? And the basic principle, we would have a rod with a jewel bearing and a sort of a weight on either end, a sphere. And the idea is that the center of mass and the center of gravity are not exactly alike. So if you spun this thing around, you would see it would sort of wiggle around. And what the approach for damping was to essentially have a rate gyro, and as you see it going this way, you cancel it with a momentum wheel. So it was gravity stabilization with merely a damping system. Excuse me a second. And of course, at the briefings, people would ask, how do you know that will work? And of course, we would point to the moon, because you always see the face of the moon facing the Earth. And for a reconnaissance camera, it turns out we later found that that's really what you want. But the original Air Force system, which was 117L, we did it right, Pat. And then, oddly enough, we were transferred to Los Angeles. I think I was the 40th one there, the only one less than a major at that time. But anyway, when Colonel King transferred it, Bob Truax, a Navy captain at the time, was on loan from the Navy because they weren't doing missiles, and General Schriever barred him, although he always thought he was a spy. I think he was the thing about to say. But anyway, Bob was there, and Colonel King at the time was where I was assigned to Wright-Patt with Coolbaugh and Tretchell, other pioneers here. We were known as the Space Cadets, and Bill King had an outfit that made jewelry, make us a little pin that was essentially representing a 83-degree retrograde orbit, which at 300 statute miles was what was required to have a constant illumination for visible satellites. All year long, the plane would rotate around if it was that. So this was an unclassified little club we had among the three of us, and Space Cadets was a very negative term. I'm laughing about it now, but it wasn't so funny. But anyway, we were transferred to from Wright-Patt. Bill King went to brief General Schriever about what he was transferring, the program characteristics and what it needed. So we already know what we want. We've already picked a rocket engine, the Hustler, which was a Bell aircraft, 15,000 pounds, that had the kind of fuel. Truax was a real expert in rocketry. That's what he wanted. When we did system contracts and studies, we didn't want any other answers. We knew what the hell the answer was. And similarly, because of MIT having all the background of doing almost all the inertial systems, and ironically, they were done with gyros that were flotation. And it turns out later, as we'll get into it, North American, who worked on the RAND programs, was very qualified in many of the ways, except for one thing. The current versions of their platforms use gyros that were air bearings. And on a simple basis, it didn't seem like such a good idea going to space with air bearings or the development to switch over what Draper had been working on for years. So we were beginning to think sole source. And to make a point that was just made earlier, General King, in front of, it was Colonel then, he was an LC then, briefed General Schriever that we have some hard-on decision made. We don't need any help from Raymond Woolridge, your system contractor, on everything else out there, which is going along with what was just said earlier. He made it quite clear, and he said, General, if you insist on doing that, you're going to delay the program a year. And that was a nerve to say that, I thought. But anyway, let's see. Now back to some stories. Corona started by essentially getting me out of the Air Force. I owed them a 3-year payback. And the last thing I did was, and I think it was 3 months after Sputnik, we gave a briefing of the status of our own military satellites compared to what we thought the Russians might be doing or where they were, having succeeded already. By then it was almost launching dogs and whatnot. But I gave a briefing and Killian was there, Lamb was there, etc. It was a very important briefing. Right after that briefing, I got a wire from personnel in headquarters ARDC. If you'd like to get out of the service early, you don't owe us a 3-year payback. And I said, oh, I'd like to get out right away. I got out and was hired by Dick Leghorn, starting ITEC, out of the Boston University Physical Research Labs, that had been doing high-resolution balloon cameras to fly at twice the altitude of the ones that had been, maybe 400 of them shot down or did no good, but by going twice the altitude, it was thought, and taking high-resolution pictures, and we were the first at 100 lines per millimeter. World War II, just for your information, was maybe 10 lines per millimeter. So that high altitude was useful stuff. And I worked on that on the navigation deck while we were getting the Corona proposal together. We proposed using the Agena because we found out that at that time the CIA already had taken a RAND recommended solution of the old project feedback RAND reports and do a spin stabilized satellite. And our argument for it was that at that time I had been working on the Air Force satellites, which were 117L, was a television system at 300 miles that was essentially gravity stabilized, as I mentioned earlier, or minus even higher altitude. And they worked there at high altitude. So when I got to work for Leghorn, he said, well, we want you to stabilize a scaled up balloon camera, panoramic camera, that goes back and forth with a high resolution telescopic lens. So it's a mechanical kludge on a roll axis of a vehicle that upsets the vehicle in an opposite way. And it was a tough job. I said, we can't do that. And he said, we also want to fly at 100 miles, not 300. I think the saying then was, if you want close-up pictures, you got to get close up. And that was the idea. So all of this is described in this video if you want to look at it. But now for a couple of interesting things that happened in Corona. One is after we got it flying and we're a success, which means 15 flights and up, maybe 20, flight number 20. The normal routine was to issue a command from Vandenberg that just as it goes over the horizon, you're going to come next pass or so, we want you to drop down, and my stabilization was designed to release it correctly on time and so forth, so that it would land within a mile on the Earth of a location. And ironically, this Loran targeting to meet it on the C-130s was using Loran, as a matter of fact. It was very successful to get us in the same area. It wasn't a precision system like I'm talking about. But anyway, this went on and worked very well, except for one time. They issued the command to come down, and they weren't sure it got through. There wasn't a good lock on ensuring reception. So they issued the command again. So what it did was do this. It flipped it 180 degrees. So instead of going to Hawaii, it went over and landed at Spitsbergen. And everybody, at that time, it was a highly classified thing. We were worried, A, is this the start of a real Cold War turning hot, or what? And of course, at that time, they had a security guy, Colonel Moose Matheson, got a C-130, put some skis on it, filled it with GIs and guns, and landed in Spitsbergen. And he was a character going all over there looking for it. They never found anything. They're not sure whether it was found or not. But it was an interesting thing. This actually demonstrated if you can bring a nose cone by command with just the final trajectory in, it's a different ballistic missile program and a lot shorter time. You don't get Midas working because we're not launching any damn thing. We've got them stored up there. Anyway, it's an idea of thinking now you're turning military. We were thinking reverse. We didn't want to start anything. Anyway, I don't know, that's probably random enough.
I think incidentally, some of you may not know this, but when it came to high altitude reconnaissance with balloons, we have one of the fathers of that sitting here, Colonel Haig, before he went into the meteorological satellite program, was running what is popularly known as Moby Dick, the Genetrix program for high altitude balloon reconnaissance. So, Colonel Haig, can you hear me?
Yeah,
Would you like to tell us a little bit about the Moby Dick balloon reconnaissance program?
sure. Back before satellites, the problem of getting information about what was happening in Russia was a very serious one. And we were having all kinds of miscellaneous stories and rumors and bad propaganda about how the Russians were way ahead of us with missile development and so forth. So some Paul Worthman and some other people who were, Paul was a meteorologist, he's a pioneer too. But anyway, he knew about the Japanese program of flying balloons over the United States with incendiaries to light fires all over our forests in the Northwest, called Furu. The Japanese Furu program was a last-ditch kind of an effort with about 400 to 500 balloons made of rice paper, reinforced with a little glycerin coating. And they carried incendiaries at the end of a very long fuse, which the fuse was lighted when the balloons were launched in Japan. And as they flew across the Pacific and the jet stream, by the time they got over the west coast, the fuse had burned out, so it started dropping incendiaries. But unfortunately for the Japanese, that happened to be a very wet year on the west coast, so they didn't start any fires. And so that whole system was a failure. But it did demonstrate that it's perfectly possible to use balloons to fly across oceans intentionally with a great deal of success. Of the Japanese launch of somewhere between 400 and 500 balloons, they believe that between 350 and 380 balloons actually made it across and could have caused havoc had it been a dry year. Anyway, Paul decided that what we should do is to follow their example, use some improved balloons and fly them across, launch them in Europe, fly them across Russia with cameras to take pictures as they went across. And that was Project Genetrix birth. He had to have somebody to develop the balloons, and that's the job I got. So we had at that time two sources: Raven Industries, a couple of young people, and General Mills, the breakfast food people. A guy named Charlie Moore had started a research program, and he was first of all researching polyethylene as a packaging material, and then he gradually went into balloons when they were requested by a few scientists, to make some balloons for weather studies. So he started out to make balloons for Genetrix, and Winds and Industries was the third one who started up then. So we had three sources. They developed balloons that were designed to fly at 45, 55, and 65,000 feet, depending on the different size of the balloon. At 65,000 feet, the balloon was 72 feet in diameter, had about 3/4 of an acre of polyethylene in it, and was an absolute bitch to put together. Imagine heat sealing with great success and not leaving any holes when you're trying to heat seal the edges of 1.5 mil. That's 1.5 thousandths thick polyethylene, the full length of a balloon that's 114 feet long, stretched out. Well, they found out how to do it. We made some really excellent balloons. I tested them by flying in a couple of them. Had some really interesting flights up to about 10,000, 15,000 feet. In those balloons, we modified the balloon slightly to provide an escape hatch on top, put a gondola on the bottom instead of a payload package, and take off. And it was a lot of fun. I always figured if you couldn't have fun on a program, there was something wrong. So we had a lot of fun. Anyway, Moby Dick ended up flying some 700 balloons from the 3 launch sites at Astoria, Oregon, Tillamook, Oregon, and Marsh Field on the West Coast. And they carried various packages, but mostly they carried a package we were developing in order to carry a camera operated by a little automobile battery in it and a whole bunch of very carefully designed insulating material to keep the film from becoming cold and stiff in the camera for a period of 8 days. And that was developed by Tufts University and a little group from the physics department there. It was an excellent package, really worked. We flew the same camera, but incidentally, with slight modifications, was used in Corona, exactly the same camera, slightly different lens on it. And we developed the mechanism for the whole process of recovering the package from the balloon. A young captain named Fouget was in charge of that part of the program. He finally trained some 14 air crews to fly C-124s, later C-130s, but mostly C-124s then, flying boxcars. To put booms out the back end of these things, put a cable between them with grappling hooks on it, and the pilot is supposed to fly directly at a descending parachute with a 150-pound payload package on it, time his flight so that he just passes over the top of the parachute. He has a total of 24 feet allowance between the bottom of his airplane and the top of the parachute. So, has to be within 24 feet when he passes over for the hooks to grab the parachute and pull the package aboard. I'll tell you, it took very brave pilots quite a while to master the technique. It is contrary to normal human judgment to fly your airplane directly at a descending package, knowing that if you misjudge and you hit it, that package will come up and smash into your airplane and probably bring you down. So but believe it or not, they got so they would get 11 out of 12 packages, every one of those 16 pilots and crews. So that's what we had on the East Coast. Flew 700 balloons across the country, and incidentally started the whole UFO craze. These balloons at sunset and sunrise, while the ground is dark, the balloon is still illuminated by the sun, and it's a very bright light. And so, in people's eyes, with various kinds of astigmatism and other things, saw that in every conceivable different way. And so we found we could track our balloons pretty well by television reports of UFOs. We tried desperately to put out information. These were weather balloons, but nobody wanted to believe that. And there was a notice to pilots, do not under any conditions try to catch one of these balloons. It's flying above your flight altitude, you can't reach them anyway, so don't go. Well, in West Virginia, an Air National Guard pilot flying the first jets that had been given to the Air National Guard stood one of his airplanes on its tail to chase a balloon going by at 72,000 feet. His ceiling is about 50,000 feet, or less, around 45,000. So he flamed out and made a great big hole in the ground, and that was the end of him. So the Air Force put out a notum, I think in red ink, I don't know. They're very insistent when next pilot tries to catch a balloon is going to get court-martialed. And so that's put an end to that. But that was the only fatality that our balloons caused that I know of among people. We were launching out of Tillamook one time, and if you know anything about Oregon, that's great cow grassland, pasture country. And then one of our packages from a balloon where we were experimenting with different kinds of lifting gas, package did not lift well, it was raining, so it didn't come up, and it dragged across the ground, clobbered a cow, and that cow turned out to be the most valuable cow as the man sued the United States. So that was the only other fatality that we knew of. But the UFO was a cause of a lot of concern. In order to field this program, after we had proven the balloons and the recovery and the package and everything, the Air Force and the CIA organized the Air Communications and Resupply Command, or some such name, a pseudo CIA-run organization. And we trained the crews and those launch sites, and they took the whole program, Genetrix, over and mounted it in Europe, But they made the serious blunder of putting their launch sites up close to the border with Russia in Germany. We told them to stay at least 120 miles away from the border. Well, that's not where they had airfields, so they went to where the airfields were, and of course there were tactical forward fields about 20 to 25 miles away from the border. Launching the balloons from those places, balloons were still rising as they passed over the border, and the Russians had very little difficulty putting up fighters to shoot them down. Well, they soon discovered that shooting holes in a polyethylene balloon below the gas bubble doesn't do any good. So what they soon learned to do was use the tip of their wing to go up and rip the side out of the balloon where the gas bubble was. That brought them down right away quick. And that's when Khrushchev ended up in the UN in New York with 3 of our cameras on his desk, pounding on the table with his shoe. Most of you are too young to remember that, but they even caught it on TV. Eisenhower was at that point upset, of course, and so he canceled the program, which was too bad because it was a pretty good program. Of the some 100 balloons they actually did launch, some of which were lost to Russian aircraft, about 28 of them went all the way across Russia, and packages were recovered from 23 of the 28, and the pictures were beautiful. Had the program been mounted properly and run properly, it could have solved most of the problem of reconnaissance over Russia at that time, before satellites. One little follow-on, a couple of years after that Genetrix was canceled, a man named Dick Braun at Cambridge Research Labs, Captain Braun, very good meteorologist, theorized that the wind above 140,000 feet reversed direction for about 4 or 5 months each summer, and actually flew from the east to the west. To prove it, he flew 3 balloons that we know of over the United States, launching them on the East Coast, up Minnesota actually is where he launched them, and tracked them across and then cut them down after they had passed the West Coast. His theory was correct, so we had learned some about the atmosphere we didn't know. So anyway, Genetrix 2 was organized, or authorized, and they got control of a pocket carrier and put a crew on it to go launch a balloon, the first one out over the Pacific, going to fly across Russia. Trouble is, they ran into a rain squall, and the launch was delayed by about 8 hours. And the State Department, for some reason, had insisted that they put a timer on the package to cut the payload down at the end of a certain time period. They didn't trust the radio controls. So that timer was set by the crew to correspond to the planned launch site, which was delayed by 8 hours. When they finally did launch it then, they forgot to reset the timer. So the package cut down right on cue, directly over the Kremlin, 2 blocks away from the Kremlin, in Moscow. That was the end of Jennifer. And Eisenhower was probably the most furious president we've ever had. He was very upset. But that's the end story of Moby Dick, the name that was put on that balloon program for publicity purposes, because it got a little more pizzazz in the newspapers than Very High Wind Field, which is the other, Vehoff was the other name. So Moby Dick was what it was known as, and that's the Moby Dick story.
Thank you so much. Nobody's raising their hand, but you heard a lot. I thought I knew a lot about that program, but I heard a lot that I didn't know. And I suspected the connection between UFOs and Moby Dick. Now we just had it confirmed. Okay, we've got Colonel Craig down there. We have one question here. You want me to go ahead and ask her? Okay. Colonel Craig, you, I guess in the short introduction that we gave, we didn't really indicate how long and how extensively you were connected with space situational awareness. So I will tell you, he started a Moonwatch program on the eve of the Sputnik launches down in New Mexico. That's really where it began, I think. And then he moved on to set up the space surveillance software as we were about to go into Cheyenne Mountain in the 1960s. And went from there to help design, maybe lead, the Space Defense Operations Center, the SPADOC, which we're now, of course, replacing with JMS. And he finished his career in uniform with leading the design of what we call the High Accuracy Catalog. So, Colonel Craig, could you just tell us a little bit about, maybe discuss the evolution of your role in space surveillance, maybe starting with SPADOC and how that all came about?
First, I would like to give a trophy to Colonel Haig. He didn't mention it, but he was involved briefly with the MOL program. That preceded Skylab, that preceded the shuttle. Air Force program that was canceled, I would say primarily for political reasons, back in the late 1960s. And I had, coming on board with the NRO, I had the first job of joining Colonel Ralph Ford in disposing of the MOL, what was left of it. And it took a while. NASA wasn't too cooperative. We wanted to give some of it to NASA. They didn't know what for. Now they know what for, but it's too late. I was going through my stuff the other day, and I found what may be the last remnant of MOL, which I'll now give to Colonel Haig, if I can get over there. Pass that over. I refused to get rid of that. That was, we had a scale model, 1/30 scale, and that was the label on it, brass label. So I don't know if there's any other piece of the MOL around. But since Colonel Haig was involved with it, I thought you might like that.
If I could just read what it says, because he can't quite read it. Is that right, sir? Would you like me to read it?
Yeah.
Okay, it is a very nice brass plate. It says USAP Manned Orbiting Laboratory Mission Module, produced by the GEMOL program. And I don't know if everyone knows what that program was, but it was a huge effort by the Air Force, but then suddenly got canceled. It was a manned orbiting laboratory that only hired astronauts whose vision was 20/10 or better. Does that make any sense? Think about it.
And if some of you aren't aware of this, the Manned Orbiting Laboratory papers, the NRO and Air Force recently released several tens of thousands of those. They're available on the NRO website. So,
Could I explain a little about MAL? When I left the Air Force, I took a job with GE, who is the contractor for MAL, as the manager of simulation and astronaut training. So that simulator that I guess this came from was a monster. It was 5 years old when I joined the program, and it was about many years from completion, believe me, and was well over budget. The purpose of the program, of course, was to do manned reconnaissance from a satellite. And if you think about that for a little while, it doesn't make much sense. It was an Air Force program which was actually to compete with the NRO program, which were doing a very good job by then in providing excellent reconnaissance coverage. But the Air Force typically wanted to put a man in space. So they proceeded with MAL until it just was obvious it was an impractical thing to do, so they scrubbed it. The simulator, well, trying to make a program like that at that time, the technology simply wasn't advanced enough to do it. The simulator required 2 separate computer systems, each one made up of, at that time, the hottest digital computer that IBM could come up with, and the other half of it being a Burroughs analog computer. The analog computer is connected to the simulator itself, and then is connected to the digital computer for instructions and jargon. But the analog computer was used because its response time was much faster than the digital computer at that time. While writing the software for a system like that, we had 280 programmers and engineers, well, 280 programmers and about 50 engineers trying to design that system and make it work. And they were already 3 years behind schedule and several $1 million over budget when the program was canceled. There were 2 such satellite systems, one representing the simulated world and the other one representing the real world. And to find problems, you measure the difference between the 2 worlds. It's a great theory, very complicated simulator, never worked.
Okay,
Can I make one comment relative to the Air Force man in space? Right after the Corona, maybe 5 units after it was beginning to get successful, I got pulled off to do a proposal for an E5 camera, which was originally to be a stereo version of Corona, but twice the resolution. We had one pretty much designed, And we spent 6 or 8 months getting into it. And the end date for the first flight of it stayed constant no matter what we did, which was a weird thing to do. But anyway, we went along with it, and then we began getting directions. Here's the configuration of the camera. It has to be pressurized, it has to be laid down. It's a new recovery bucket. It actually was a mercury capsule that had to be the space and weight exactly like it. We built such a camera, and at the last minute, they said, oh no, you've got to have the center of gravity on reentry much more further forward. So we actually designed 2 screws that took a 300-pound lens assembly and move it down the length of the thing, and so forth. And then we flew 3, and right then Mercury succeeded, and the program was canceled. That was it, because we never recovered or got nothing ever worked. 35 years later, Dwayne Day interviewed me straight for 6 hours in my apartment, not too long back, and he published Spaceflight, I think, The Rising of the Phoenix or something like that, because later this thing was converted to lanyard without all these things and using the same Agena, the same recovery bucket, and so forth, with just a 66-inch F5 length. But anyway, it turns out nobody could ever figure out, and the 5 Spaceflight articles don't distinguish whether it was the contractor doing it or Air Force direction or RW or whom. It was just a fuzzy thing that happened, and it was what was later called MISS, Man in Space Soonest. Now, whether it was a mission race to NASA or a backup to NASA, who knows? That's
And it was the MISS program that
Somebody
we
knows.
sort of handed over, we, the Air Force, sort of handed over to NASA that became the full-fledged Mercury program.
yeah.
A lot of those documents have been declassified as well, and we do have a classified version of the MISS program in our archive.
One last comment about the unfortunate demise of MOL. As the Gambit mission planner and targeteer, I was accosted by OMB to run through details on how many dollars per picture Gambit took. And Gambit photography cost about 5% of what one picture from MOL had. And OMB used that in the cancellation of the MOL program.
Another fact that you probably never would have heard had you not been here today. Okay, now, I want to give Colonel Craig a chance to talk a little bit about SPADOC. How that
Favorite
came
date
about.
for everybody is 4 October 1957. It was within what was called at that time the International Geophysical Year, which was really a year and a half. And the Air Force had been, and NASA and everybody had been planning on having a NASA launch during that time period. And then along came Sputnik 1. And a couple of us were down at Kirtland on the computers figuring out orbits for Sputnik 1 and getting telephone calls that the Soviets couldn't have done that. It's all a fake. And there went the satellites, and he was like, well, and that was kind of the beginning. And then somewhere along the way, the Air Force Academy wanted me to teach astro up there at the beginning of the academy. And I said, I'm not qualified. So we started the first aerospace control squadron here in Colorado Springs. And the problem was that they wanted to provide a military capability to detect, track, identify, and catalog all man-made objects in space. And we're going to provide, the Air Force is going to provide a new NORAD with this capability under something called NORAD SPADAX, Space Detection and Tracking System. This is the late 50s. So in 1961, Thomas D. White, Chief of Staff of the Air Force, said, okay, the Air Force does want to do this. The Navy chimed up and said, no, the Navy would rather do it. They could do a better job. And that started General White sitting in the surveillance chair at what became Air Force Space Track, lecturing us on, you will have an operational space surveillance capability providing data to NORAD by 1 July of this year, period. And we made the cut. But the early days were kind of interesting. Right now we have 25, 30,000 satellites that are technically catalogable. At that time we had about 60. And it was kind of a leisurely operation, which orbital analysts would have 5 or 6 satellites they would take care of. They would provide data to sensors on a periodic basis. Now, when you're tracking satellites, it's not just one orbit determination. You've got to allow for a lot of changes, atmospheric drag, among other things. So you have to continually update the orbits so that you don't lose track of the satellites. So we had about 20 sensors worldwide, taking different types of data format and whatnot. And the job of the analyst was to provide his set of sensors with data in their format so they could go out and look for the satellites, collect data, send it back to Colorado Springs, and we would update the orbits. That was a very simple way of doing things, and we wouldn't lose track of satellites. Well, on 29 June, remember we had to be operational on July. 29 June, there was a launch called, at that time, 1961 Omicron. And it was the first multiple payload launch. Transit 4A, solar radiation 3, and engine. Those are the 3 payloads. The upper stage booster was an Ablestar, and this was a Navy launch. So I call this the era of Navy revenge. The astronaut of supporting Colorado Springs with space surveillance. So what happened was this. They launched. We had the 3 payloads. And then all at once the sky was cluttered with satellites. And we had the first beam use up. It wasn't really technically operational, but we ended up with hundreds of targets. Now remember, we've been operating leisurely with 60. Now we had hundreds of targets. And we've got 4 big tables out, and we've got the world's largest roll of K&E graph paper, and started plotting these things up. 500 satellites. This was 80-hour weeks. And we weren't happy. And then I was talking to the Navy. You know, your Ablestar blew up. What happened? And this guy confessed. He said, "Well, we were finished with the launch. We were cleaning off the dais, and some guy was just idly punching buttons, and the Ablestar booster with its self-destruct package flew over, and the signal hit it and blew up." Thank you, Navy. So we went from 60 to 500, and that started the era of everything changed. Needless to say how it changed. By the way, every year we get a package into NORAD, the Navy offering to take over space surveillance. Bill Craig was always picked, since he had the right attitude, to answer that on behalf of the Senate, which said, hell no. Time went on, and we were having fun, and we were trying to put everything into Cheyenne Mountain. Well, first, being the first on the block, you get a chance to be the first in a bunch of things. That we got the first accurate satellite reentry prediction, Sputnik 4, and it was a piece of iron manufactured in the Soviet Union in the middle of an asphalt road, smoking. The police didn't know quite what to do with it, but that was Sputnik 4. And we accurately predicted it. We came within a few miles of where it was supposed to be, which is probably more of an accident than. And then we had some other things. The Russians, we had a lot of fun with the Russians. This is Cold War. Everybody hates everybody. The only communication we had with the Russians was through Coast Guard. This is maybe on outer space stuff, which was international, and they cooperated there. Anyway, we had the international responsibility for correctly cataloging satellites. So we had changed the numbers instead of 1961 Omicron stuff. We ran on the Greek alphabet pretty quick, but numbers never quit. And we were cataloging, well, we got orders, the Russians would not announce one of their launches unless it was a success. If it was a failure, you never heard a word. But it was a launch, so we were burning up numbers. The international community wanted to know where all the numbers went. And in this Coast Guard organization, we said, well, it calls it like we sees it, and these were launches. Satellites in orbit. Whether they work or not our problem. So after a lot of feathers and worry, the Soviets decided in the interest of international conformity, they would agree with our numbers, which was a Cold War success, I'd say. And then we had, well, in this process, this is 1962, the Russians had launched 6 satellites to interplanetary targets, specifically Venus and Mars. And there were 3 launches, Venus, 3 launches Mars. The first 5 were dead, didn't go anywhere, we cataloged. And then the last one was a Mars launch, and it looked like it was going okay. And so we were trying to find it. I was out there using Dr. Heinz's new electro-optical system down in Northern Mountain, New Mexico, which was the first electro-optical. I found an asteroid, 1627 Ivar. I didn't find Mars right away. But then all at once, the Russians, the Soviets, quit. They had been announcing the position of this hopefully successful Mars launch. They quit announcing. So got a hold of a friend at JPL, got a hold of his friend, New York Times representative in Moscow, who sprung the question on the Russians. And all at once we started getting data out to years. Of course, the satellite was dead. Then we found it, cataloged it, and that's the first time we caught an outer space object. But like I say, it's nice to be first. Now, earlier, Rick had mentioned saying something about our 437 program. As most of you know, that was our Thor-launched, IRBM Thor-launched anti-satellite program. So what we had was operated out of Colorado Springs, was 2 launch sites at Johnston Island and a Baker Nunn camera sitting off in an adjoining island called Sand Island for calibration. And we would launch the IRBMs at real satellites, rocket bodies and whatnot. And the idea was we had to, in order to have a viable anti-satellite system, we had to come within a lethal radius of a nuclear weapon, nominally 1 kiloton. So that gave us a good miss distance. We weren't really scared about hitting anything. And so in the process, we had, well, first we had to get software. TRW was trying. I ended up having a competition, and we did aerotronic for aerospace software, high accuracy. And what we would do was compute orbits in Colorado Springs, and then refine the orbits data. And then we had what was called a compound terminal, where we'd take these Hollerith cards, these IBM cards, 6 of them, 7 of them, and as we got better and better, we'd run these cards through the terminal, and we would send the data to Johnson Island. We had a lot of fun with that. I remember one time we were launching, and the analysts knew where everything was, but the administrators didn't. So we had cables stacked with these IBM cards all over the place. And I remember one day there was a panic because Craig went in and was searching through the piles of cards, and he reached in, pulled out a stack and said, aha, put it in the compound terminal, and we launched. And that frightened everybody. We didn't see how possibly it would work, but we had, while I was there, 7 successful launches. All of them were successful, in the sense that the Thor would pass within a lethal radius of the target. And in one case, we almost hit the target, which got everybody to death. So that was our first active anti-satellite program, and that caused the Soviets great concern. And they cranked up on their anti-satellite capability. That's another story. Later on, I had strategic defense R&D responsibility at the Pentagon, and I had 36 programs, everything except the AWACS. And one of those was the F-15 ASAT. And so I was constantly fighting with the system because it cost so much money. Each ASAT launch was $1,200, I think. And General Jasper Welch was on me about once a week on that thing. It cost too much money, not worth it. And we went through a lot of that drill. And I came, almost got shot, went down to attack. And the F-15 was air-to-air, of course. Air-to-ground was a real add-on. And then when Craig came rolling in and briefed everybody on, we got one more, and that's ASAT. That almost killed it right there. General Russ was apoplectic. Too many missions for the F-15. So anyway, F-15 got canceled. A lot of people lament that. Now, in Cheyenne Mountain, it went operational April '66, and in '65 and '64, we discovered that none of the planners had decided to put space in the mountain. No planning for satellites. And that was a little weird. But we ended up developing a Tiger team, and we rewrote all the 72 programs for satellites. And we ended up putting it in the mountain. It worked just fine. Delta project. So those were some of the beginnings. Now, later on, let me, time is getting short, let me jump to the end. There was a big issue about accuracy of the catalog. And of course, the more accurate you are, the better everything. So we had the standard general perturbations, low accuracy data, which was every day generate the catalog, spread it to the world. And some of us had done some studies, and the Air Force Scientific Advisory Board had gotten involved. And the bottom line was, hey, we can make the whole catalog high accuracy within the 8-hour shift time limits. So let's do it. And all at once there was a lot of political flack. The Navy rolled in and said, we'll do it. So I took the bull by the horns and briefed the NRO and the SINC, and I said, okay, we've got a plan. We're going to get the right computers, and we're going to prove that we can do it. And we're going to establish an initial operational system, and do that within 6 months. Well, I got everybody's attention and got my high up there for shooting at. But NRO provided the computers, we got the computers, and we managed to handle the entire catalog in something like 4.5 hours. High accuracy. You know, 3, 5 to 10 times as accurate as the general probation's catalog. No more problems with additional new computers or anything else. We already had the computer. So that's where the high accuracy catalog came from, and then I think that was a real contribution to Space Rail. I think I'll stop right there.
Well, ladies and gentlemen, overtime. And things were just starting to get interesting. But please join me in a round of applause. Thompson will give some closing comments.
Thanks, Rick. And gentlemen on the panel, thanks so much for your insights and perspectives and for all that you've done for us over the years. Let me personally say thank you for sharing all those anecdotes about talking back to general officers. And for the staff, I think the tone of my meetings with the staff is about to change. For all the staff, let me say in advance, I love you too much to kill you. We're going to go ahead and do it. But again, so I hope all of you have seen a couple of things here. In many cases, the types of issues, the things that you deal with, that you're challenged with every single day, in many ways, while the names have changed, the faces have changed, perhaps the nature of the challenges have changed. The fact is, from the earliest days of space, the fact of life is, those that persevere, those that know, those that understand, those that work hard and never, 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 never quit, are those that achieve and succeed. And I hope you see that in these individuals, but also in the work that we need you to do every single day for the Air Force, for space, for cyber, and for the nation. And gentlemen, I thank you for that example and for what you did for the first big things in space and for inspiring our staff who we expect to do the next big things in space. Again, let's have a round of applause.
Sir, and I might just add that if some of you want to personally greet some of our pioneers, they'll be down front unless they have other obligations. But that concludes today's events, and I think we've all heard some eye-opening stories here today. Thanks again so much, gentlemen.